right. So yesterday we talked about transformations using just the constant function and the linear function. Today we're going to do absolute value functions, which is actually easier to see it all because you're graphing something that's not quite so straightforward, which sometimes when you get a little bit more complicated problem, it's actually easier to see things, I think. So we're going to take and graph an absolute value, the parent function for an absolute value, the easiest absolute value that ever was. So really, let's just start like y'all did when you were younger and you made a T-chart. Let's just plug in some numbers and go the other way. So if I'm doing the absolute value 0, I'm going to get 0. Absolute value 1, I'm going to get 1. Absolute value 2, I'm going to get 2. Absolute value 3, I'm going to get 3. Absolute value negative 1, I'm going to get 1. Absolute value negative 2. Absolute value negative 3, 3. So we got a bunch of ordered pairs. 0, 0. 1, 1, 2, 2, 3, 3, 4, 4, 5, 5. If we had written that down, which we didn't. But I think you got the hang of it. An absolute value looks like a big V. When I was in high school, my math teacher on Fridays would tell us to graph an absolute value. So we could have a V for victory. Yeah, that's how she was. I thought it was hilarious though. Okay, so we're talking about a domain. Domains and ranges are so easy to see on a graph. So like every single one of these x's associates to a number. Like I can plug in any value of x that I want. So the domain for the absolute value parent function is just all real numbers. But see how the lowest it ever is 0 and everything else is above there? That means the range is all y is greater than or equal to 0. Now remember, lots of times you're going to see this in a lot more, I don't know, mathy looking way. So you might see the range is all the y's that are elements of the real such that y is greater than or equal to 0. We're keeping it pretty straightforward. I'm just going to say y is greater than or equal to 0. Or you might see all y's such that y is greater than or equal to 0, because a lot of people assume that if you don't tell somebody, well, I guess it's not an assumption because we all kind of do it. If you don't tell your reader that you're talking about the real numbers, you're talking about the real numbers. So if you want to talk about some other set of numbers besides the real numbers, you need to designate it. So anyway, now we're going to look and do a bunch of transformations on just that regular old parent function. So let's go through here first. We'll do this super quick and just graph that parent function. I'm just going to do it real lightly. Actually, I know what I'll do it with. I'll do it with a highlighter. And then we'll just have it on there to compare to. Oops, it's too thick. Okay. So we're just going to compare every single one of these back to the parent function and see if we can't figure out what all the numbers and negatives and whatnot do. So whenever I change the equation, how is it going to change the graph? Okay, that's plenty. So we have our parent functions graphed every time. Now let's take, and again, just so that you can see what's happening, I'm going to do a T-chart. We're going to plug in some x, and we're going to do the opposite of the absolute value of x. So if I did the opposite of the absolute value 0, absolute value 0, 0, the opposite of that, still 0. Opposite of the absolute value 1. Absolute value 1's 1, opposite of that's negative 1. The opposite of the absolute value 2, negative 2. The opposite of the absolute value negative 1. So the absolute value negative 1 is 1, the opposite of that, negative 1. The opposite of the absolute value negative 2, negative 2. So look at what just happened to our graph. The green one is this. Compare it to that parent function. We reflected about the x-axis. Or remember, our book says reflected in the x-axis. Some people say it's reflected over the x-axis. It's all 6 of one, half dozen other. It means the same thing. So go back and look at your equation and figure out, oh, what made that happen? Sticking a negative out in front of the parent function just flips it upside down because you're taking all the answers that you had before and finding the opposite answer. That makes sense. Okay. All right. So this one, we're going to do the same thing. Let's see what happens when I do the absolute value of x and I add 3 to all those values. 0 plus 3 is 3. 1 plus 3 is 4. 5. Okay, see what's going on that way. Absolute value negative was 1. Add 3 to it. 4. 2 plus 3, 5. So we got 0, 3, 1, 4, 2, 5, negative 1, 4, negative 2, 5. It's the exact same shape. It's just translated 3 spaces up. So it moved it up. So it's this is your notes. Let's make this look good. It's a vertical shift that moves it up 3 places. Okay, so go back and look at the equation. What made that happen? Oh, I took the answers I had before, the parent function, and added 3 to them. Because what I'm figuring out is what y equals. Well, the y is the up and down part on our graph. So if you take the values and add 3 to them, that's what you do to your y values. They should move up 3 places. Okay. All right, let's try this. Try those same numbers. Absolute value of the quantity 0 plus 2. Absolute value of the quantity 1 plus 2. Okay, well that just seems to keep getting bigger. If I did negative 1, that'd be 1. Absolute value 1's 1. There's 0. Oh, here they're getting smaller. What happens if I move on to negative 3? Absolute value negative 1's 1. Oh, it's coming back up. Absolute value negative 2 is 2. So look at this graph. We got 0, 2, 1, 3, 2, 4, negative 1, 1, negative 2, 0, negative 3, 1, negative 4, 2. If I did negative 5, it would be up 3. So it's the exact same shape as the parent function, moved 2 places to the left. So it's a horizontal shift, which we didn't do yesterday. I went left 2 places. So go back and look up here. Let's compare these. If I just stuck a plus 3 out on the end, just picked it up, moved up 3 places. To go 2 places to the left, though, look, I have a plus 2, but it's not out on the end. It's in there with the x. Because I always kind of think about, like, what value would I, because the parent function, the y value right there where the point of the v is at 0, what x value do I have to put in there for that to equal out to be 0? Well, I'd have to put a negative 2. So I'd get the 0 in there to take the absolute value. That means I'd have to move everything 2 places to the left. So when you move them sideways, it kind of looks like the opposite of what you think it's going to be. Things that move up and down, it looks exactly like what you think it's going to do. You move it side to side, it looks like the opposite because you've got to put it, because basically what's happening is when you just stick it out on the end, you're just applying that 3 to whatever the work was. Like I took the absolute value something, added 3 to it. You know, that's just tagged on at the end. That's going to change the answer that flat out changes the y. Y moves up and down. When you put it in there with the x, though, like it's x plus 2. And then once you do that, then you take the absolute value of it. You're putting it in there before the absolute value is even considered. So that's why it has to do something different than the other did. Okay, let's do the same thing here. Let's see what happens. Absolute value 0, 0 times it by 4 is still 0. There's a 4. Here's an 8. Ooh. Also 4, because absolute value negative 1 is 1 times 4 is 4. Here's 8. So let's look at this. Everyone up 4. Over 2 up 8 is going to be on up here someplace. So it didn't move it. It didn't translate the graph. It didn't pick it up and move it anywhere. The point's still right there at the origin. I got kind of an ugly looking graph. But what it did is it made it a lot skinnier. It grew quicker than it did before. Like on the regular parent function, when you plug in a 1, you get out of 1. On this function, when you plugged in a 1, you got out of 4. So that was a vertical stretch. Because it's got to grow 4 times as fast as it did before. All right. This one. Okay, there's a 0. There's a -1/2. All right, opposite of A2 is 2. Half of 2 is 1. Opposite that's -1. Let's do... So let's jump up to 4. Oops. Because opposite of A of 4 is 2. Half that's 1. Opposite that's -2. So let's just do the easier numbers. You know, remember, this is your independent variable, whatever it's a function of, that I can independently choose those on my own. I can pick whatever numbers I want. I'm going to pick the numbers that aren't necessarily fractions. So if I put even numbers in there when I half them, they won't be fractional numbers anymore. So, all right, opposite of A, -2 is 2. Half 2 is 1. Opposite of that's -1. Opposite of A, -4 is 4. Half that's 2. Opposite of that's -2. So let's look at this graph. Over 1 down a half. Over 2 down 1. Over 4 down 2. Back 2 down 1. Back 4 down 2. All right. So it's not the same shape as it was before. It's a little flatter. It's fatter than it was. It didn't grow as fast. Like right here, this was 1, 1. Right here is 1, -1/2. It's growing half as fast as it used to, and it's upside down. So there's two different things going on right there. First, we had a vertical compression or shrink. And this thing got reflected about the x-axis. All right. Last one of these. Let's see what happens. Now, before we plug in the numbers, think about it for a second and see guess what you think it's going to do. Now, I'm not going to pause because it's a video. You could pause the video and see what you think it's going to do. In class, we're going to pause and see what you think it's going to do. But right now, I'm just going to go through and plug this in. So let's see, 1, -1, 3. There's a 2. There's a 3. There's a 2. There's a 1. Oops, disappeared. -3, there's 3, -3, there's a 0. Oh, let's keep going that way. 1, -4, there's a -1. Okay, so let's put some points on here. We've got 0, 2, 1, 3, 2, 2, -1, 1, -2, 0, -3, -1. This. Let's just keep it up that pattern. Let's check and see if we're right. Like right there's the point, what, 5, -1? Let's see if that's what would have actually happened. Yep, looking good. So 3 transformations. Let's think about what each one did. That, negative out in front, reflected the parent function or the graph of the parent function about the x-axis. And then we move one place to the right and up 3. So we flipped it upside down. That would look like this. We went one place to the right and up 3. Oh, there it is. Okay, so last one for today. It says identify the function family to which f belongs. Okay, obviously that's some sort of transformation of the absolute value, which covers this. Compare it to the graph of the parent function. So let's do the same thing. Let's put the parent function. Oh, too thick again. We'll do that in a highlighter again. I'm not worried about getting exactly where it needs to be. Let's change colors. Okay. Give the domain a range. Okay. All right. So let's see if we can think about what's going to happen just by looking. Will it be flipped upside down? No, because there's no negative out front. However, there is a number besides 1 out in front of where the, because remember, we're comparing just plain old absolute value. 2/3 is between 0 and 1, which means this is it's not gonna grow as fast as usual. Remember, if that number out in front is higher than 1, then it's gonna grow quicker. If it's between 0 and 1, it's gonna grow slower. So it's gonna grow 2/3 as fast as it usually does. So there's gonna be a vertical compression or shrink, like our book says. We're gonna move 2 to the right and down 3. Okay, so 2 to the right and down 3. That's where the point's going to be. And then just think about it. If it's usually when this thing moves, it's over 1, up 1, over 1, up 1, over 1, up 1. So we're going to do this 2/3 as fast as usual. So we're going to go 2/3. It's basically like the slope of half the graph. Okay? Because you want it to be when you moved over 1, you want to be up 2/3 as far as usual. So move over another, and you want to be up 2/3 as far as usual, which then gets you at 4/3. Then over 1, up 2/3 as far as usual. But if you think of it like the slope, it's a lot quicker. Like, oh, rise 2, run 3. Rise 2, run 3. Oops. All right, this appeared on me again. Okay, rise 2, run 3, rise 2, run 3 the other way. And if I want to make sure I'm correct, I'm going to check that point right there. It looks like it's at 8-1. Let's see if that's where it would actually be in. Absolute value of 6 is 6. Keep trying to make that a plus. The third of 6 is 2 times by 2 is 4. Oh yeah, that's exactly where it would have been. That's where I thought it was. So in my domain, I can plug in anything I want. The lowest this thing ever got to was -3. So all my y values are going to be -3 or higher. All right, another day's notes done.